Please open in your learning workbook to page 177. Let's solve two ALEKS problems involving transforming exponential function graphs. Below is the graph of y equals 2 to the x power. Translate it to create the graph of y equals 2 to the x plus 4 power, subtract 3. Okay, so this is a classic example of a parent function and a transformed function. Now, the exponential function was not one of our flashcards from earlier in the semester when we studied transformations. However, it's functioning as one of our flashcards now. So let's go ahead and write down not only the graph, but the points that we know to be on the graph. We've actually studied this exact graph in a previous video. The points that we got for x were -2, -1, 0, 1, and 2. And the points that we got for y were 1/4, 1/2, 1, 2, and 4. At the time, that video actually included some other values for x as well. The 3 and the -3 were also in there, so we got 3/8 and -3 1/8. But we can live with the points that we have here for now. All right, so parent function, and these are the values that are associated with it. But now we're going to transform it. Whenever you transform, you have to ask yourself what changed and where. So we're comparing this, 2 to the x, to this, 2 to the x plus 4 power, subtract 3. So what are the changes that we observe, and what kind of transformation do they represent? Let's start with the exponent. X becomes x plus 4. That change, the plus 4, is inside close to x, which makes it a horizontal something. The change is adding or subtracting a number, which makes it a shift. So this is a horizontal shift. We recall that horizontal feels backwards of what we would think. So this plus 4 is actually 4 steps to the left. All right, then the other change that we observe is this right here, this subtract 3, which is outside far from x. So that represents a vertical. The fact that it's adding or subtracting makes it a shift. Now, vertical shifts behave exactly the way you would expect. Add is up, subtract is down. So this is subtract, so this is down 3. So if we want to create the new graph, the graph that goes with this equation, all we have to do is take this graph and change all of the coordinates so that it shifts left 4 and down 3. Let's see if we can figure out how to do that. All right, let's say you wanted to shift left 4. Then what's happening to the x's? You're subtracting. So subtract 4 from the x's. So for our x's, we're going to subtract 4, and that'll give us our new x values. All right, how about the y's? Well, when we're moving down, down is also indicative of subtraction. And so with the y values, we are going to subtract 3. So y's subtract 3. X's subtract 4. Y's subtract 3. You squeeze x's in here just for clarity. X's subtract 4, and y's subtract 3. Okay, great. Now we can start filling things in. All right, so here we go. So -2 is an x. Subtract 4, and it becomes -6. -1 subtract 4 is -5. 0 subtract 4 is -4. 1 subtract 4 is -3. 2 subtract 4 is -2. 3 subtract 4 is -1. These are our new x values. Okay, let's do the y values next. Let's work from the bottom to the top. 8 subtract 3 is 5. 4 subtract 3 is 1. 2 subtract 3 is -1. 1 subtract 3 is -2. Half subtract 3. You have a couple of choices here. You can do it paper and pencil and come up with the answer, -5/2. That's the choice I hope you'll make because working with fractions requires practice, and the more practice you get, the better. Or you can simply pick up your calculator and in the calculator put 1/2 subtract 3, and you're going to get -5/2, or it might say the decimal, -2.5. 1/4 subtract 3. Well, that's like saying 1/4 minus 12/4, so that's -11/4. All right, so now all we have to do is plot these new points, and we'll have our new graph. All right, so -1, 5. So that's actually going to be just a little bit off the grid here. So I'd say that that point is maybe located there. -2, 1 would be here. -3, -1 would be here. -4, -2 would be here. -5, -5/2. Well, -5/2 is -2.5. So we're talking at that spot right there. And -6, -11/4. -11/4, let's see, that would be 2.75. -2.75, which would be about right there. And so our new exponential graph is going to look like this. All right, how about that asymptote? Is the asymptote going to move? The answer is yes. When you move an entire graph, the asymptote moves with it. So when you take a line that's horizontal, like this, and you move it left or right, does the line change? The answer is no, because it goes forever in both directions. But when you move it up and down, does the line change? The answer is yes. When a horizontal line moves up, it's now at a new location. When a horizontal line moves down, it's now at a new location. So what's the new location of this horizontal asymptote going to be? It's going to be down 3 from where it started. It was at 0, a height of 0, but now it's going to end up at a height of -3 because it's moving down 3 spaces. So our asymptote goes at this location, and that gives us our final picture. This and this have the exact same shape. The only thing that's different is that this moved 4 spaces to the left and 3 spaces down, and this is the new picture.